video I'm going to show you the process called integration by recognition, which is actually a process where you have some information, you differentiate it, and you use that result to formulate an integral equation. Usually there's a part that says, and hence find the integral of something, and you're supposed to use what you found in the beginning to then formulate the integral of what you've been asked to. So I've actually been doing this process in some of my videos, particularly the trig one and the exponential integration videos. So here's one I did in the trig video. If you're given y equals cos 2x, differentiate this. So you get y dx equals 2 sine 2x. Sorry, negative, because we're differentiating. Now, what we then do is we set up an equation and we say, well, the integral of this is this plus c. Now, it's this process of setting up the equation that is where we're looking for that recognition, where we're wanting to do something. So let me give you an example. So let me just set this up. Part B of the question might say, and hence find the integral of sine 2x. So part A is find the derivative of this, and then part B is use this relationship that you found in part A to find the integral of only sine 2x, or it could say something like 4 sine x or something else. All right, so what we're now going to do, we're going to look at this and go, okay, this is an equation. I've set this up. What rules can we use? Well, we know we can pull out the constant, so negative 2, because that doesn't alter, becomes sine 2x. Now, actually, this is what we want, but we still have this negative 2, so we do need to deal with that. So let's write the equation. Don't forget the right-hand side, so we have a left-hand side and a right-hand side. And the left-hand side has a negative 2, which we don't want, so I need to divide both sides by negative 2, which leaves me with the integral of sine 2x on the left-hand side, and on the right-hand side I've got 1 over negative 2, which is negative 1/2 cos 2x plus c. Now, by differentiating this function in the first place to give me that, enabled me to set up a relationship and use my process of recognition and my manipulation of equations to then help me find the integral of this. And this process is called integration by recognition. I'm going to do a couple more examples. I'll just clear some space. All right, so if we let a function f of x equal the natural log of x squared plus 1, part A says find f dash of x. That means differentiate. And then part B says, hence, integrate this function with respect to x. So let's do part A. Straightforward chain rule. So the integral, differential, this becomes f dash of x equals, well, with this we do 1 over this, because this is like our x, so it becomes 1 over x squared plus 1 multiplied by the derivative of our bracket, which is 2x. And so simplifying that gives us f dash of x equals 2x over x squared plus 1. Now, part B says, hence find the integral of x over x squared plus 1. Well, what we have to do is we have to set up an equation with our derivative. We can say that the integral of this equals that plus c. So let's do that first. It's the integral of 2x upon x squared plus 1 with respect to x equals this, the natural log of x squared plus 1 plus c. All right, now the idea is we've got to get this to look like this. What we can do is we notice that there's an extra 2. This is if we see the difference between this and this has been multiplied by 2. So we can pull 2 out as a constant, which leaves us with x over x squared plus 1 to x. Now the right-hand side hasn't changed. We haven't done anything, so we leave it as such. Now, we need to get rid of this. So this is currently multiplying, so we just divide both sides by 2. Leaving us with, and I don't know if I've got too much room, the integral of x over x squared plus 1. That just off the bottom of the screen there, apologies, equals, I'll just try and write up higher, 1 over 2 natural log of x squared plus 1 plus c. And that is now the integral of this, and we have our answer. All right.